Welcome to DB Workshop channel. Today we will discuss few operations on the binary numbers. Let's start. In this session we will cover how we stored unsigned numbers, how we stored signed numbers, how we add binary numbers, how we subtract binary numbers, and we will also discuss the 9's complement methods and 10's complement method. Then we will discuss 1's complement method and 2's complement method. We already know how to store unsigned numbers, unsigned binary numbers. To store unsigned binary numbers, we don't have any signed bits, so we simply convert the decimal number into binary number and store them. If we have a four bits over here, then at max we can store 15, and we will start from 0, and at max we could store 15, as you can see on the screen. Let's proceed to the next slide. In order to do the addition for binary numbers, we need to know these four rules. And so the first rule is 0 plus 0 is 0, and the second rule is 0 plus 1 is 1. Third rule is 1 plus 1, that is 1 0, that is 2 in decimal. And the fourth rule is 1 plus 1 plus 1, that means 3 in decimal. So in binary we represent it as 1 1. So let's add these two binary numbers. So we have these two binary numbers and we will start adding it. So first of all, we take the rightmost bit of the both numbers and try to add them. So if we see that we have to add the 0 and 1, and because we refer to the rules, and 0 plus 1 becomes 1, so we write 1 over here. And then we proceed to the second last bit of the both numbers and we will try to add them. So 1 plus 1, as per the rule, we know that 1 plus 1 is 1 0, so we write the 0 and 1 will be carry forward. So now we have to add the third last bit of these two numbers, and we got 1 1 and 1. So as per the fourth rule, we have to uh, add it as a 1 and 1, so then it becomes 1 and carry forward 1 to the next bit. So the last bit is 1 1 and 0, and it becomes 1 0. So now let's learn how to do the subtraction on binary numbers. First of all, we see that how we subtract the decimal numbers. Now we know that how we subtract the decimal numbers. So we can use the same method to do the subtraction with the binary numbers. So first of all, we refer to these four rules. So rule 1 is 0 minus 0 is 0, 1 minus 0 is 1, and 1 minus 1 is 0. So these first three rules are very simple, and the fourth one is 1 0 minus 1. So 1 0 means 2 in decimal, so if you subtract 1 from 2, it becomes 1. And if we have to subtract 1 from a 0, so we don't know, we cannot subtract it, so we have to take the carry from the next bit, and then 0 becomes 1 0, and then we could subtract it. Let's see this example. See, if we have to subtract 1 0 1 0 1 dot 101, and then we have to just align with the decimal point, and then we will start with the rightmost bit. So if we have to start nothing from 1, we get 1, and then if we have to subtract 1 from the 0, we know we cannot do it, so we have to borrow. So we have to borrow from the next bit. So the third last bit has a 1, but if it gives it to a neighboring bit, so it will remain with a 0, and this bit becomes 1 0. So if we subtract 1 from 1 0, that's the rule over here, so we got 1. And the third last bit has a 0 over here, and if we have to subtract 1 from the 0 again, so the same process repeats again and again, and we could do the subtraction. So if we notice one thing, when we do the subtraction for the decimal numbers, we know that we cannot subtract a bigger number from a smaller number. How we do it? We just adjust the sign, and we just subtract the smaller number from the bigger number and then adjust the sign and put the sign in front of it. So the same method we could do for binary numbers also. So one more example over here, we have these 4 rules written over here, and diagrams so that how we just did the subtraction. Now coming to the negative numbers, how we store the negative numbers in the computer. So assume we have a 4 bits only and we have to store the numbers. So to store 4 bits, let's assume that the most significant bit, that means the leftmost bit, if we use for a sign bit, for example this bit over here. So if we say that this is for a sign bit, and we say that 0 is for plus and 1 is for minus, so now we remain with only 3 bits. So how many numbers we could store in 3 bits? 0 to 7 bits we could store from 0 to 7 for positive numbers. And if we assume that these ones are minus, the minus sign for it, so then we remain with these 8 values over here. So now let's assume that if we use the 2's complement method to store the negative numbers, and this is a very smartest way how they stored it. They use the 2's complement method. Let's talk about what is the 2's complement method. First of all, they start with the minus 8 over here, and they represent the triple zero with the minus 8. How is that possible? What they did, first of all, they just took the 1's complement of these numbers and add 1 to it. And now because 1's complement for this number becomes triple 1, and we add 1 to it and it becomes 8, and because the first bit is a minus, we put it as a minus sign over here. So this is how we stored negative numbers in a computer. And then for the next number, they stored 001 as a minus 7. How they can say that 001 as a minus 7? Let's see. Because this is first bit is a minus, they know that this is a negative number. Now they know that this is a negative number, they know that they have to find the 1's complement of it. So after doing the 1's complement, they got 110, and they have to add 1 again to get a 2's complement. So it becomes 1 1 and 1 again, so it becomes a 7. And we already know that this is a negative number, so we got it minus 7 over here. So this is how we use the 2's complement method to store negative numbers in computer. Let's talk about a 9's complement method. Assume we have to subtract these two numbers, and we don't have to use the subtraction, we have to use the addition for solving this problem. How we can do that? So first of all, we have to find the 9's complement. For example, for any number, if we want to find a 9's complement, we have to find a number so that which can be added to that digit, it becomes 9. For example, for 4, if I want to add something into it and it becomes 9, the number is 5, because if I add 5 to the 4, it gets 9. So in this way we have to find the 9's complement for each digit. For 2, 3, 4, if I take the 9's complement, I get 765. And now I have to do the addition. Once I do the addition, if I got the carry, and I have to apply this rule, I drop the carry and add 1 to it. So now I drop this carry and add 1 to the number, and I got the correct answer. There may be a situation that when we don't get a carry. For example, in the next example, we don't have any carry. If we do not got a carry, then it means that we got a negative number. And so now, because we don't have a carry and we have a negative number over here, we have to find again the 9's complement, and we have to put the minus sign over there. Now proceed to 10's complement. So this is very similar to the 9's complement. So let's see this example. If we have to subtract 2, 3, 4 from 6, 7, 8, we have to find the 10's complement. 10's complement is nothing, but we have to find the 9's complement, and we have to add 1 to it. So we got 7666. 766. Now after addition, if we got the carry in 10's 10's complement, we have to ignore the carry. That's it. There may be some other situation when we got no carry. If we got no carry, that indicates that it is a negative number, and now we have to put the minus sign over here, and we have to again find the 10's complement. And in order to find the 10's complement, we know that we have to find the 9's complement and add 1 to it. Now we have a 1's complement. 1's complement is very similar to 9's complement, whereas 2's complement is similar to 10's complement. Let's do this example. Consider a situation where we have to subtract 0 1 1 from 1 0 1. So now we don't want to do the subtraction, we have to solve this problem using addition. So the technique we are using here is a 1's complement. So in order to do the 1's complement, we have to switch the 0 with the 1 and 1 with 0. For example, wherever we have found the 0, we will mark it as a 1, and wherever we have 1, we have to write 0 over there. So the 1's complement for 0 1 1 is 1 0 0. After finding the 1's complement of negative number, we have to do the addition of both numbers. If we found the carry over here, then we have to drop the carry and we have to add 1. So this is the process. We have to remember this process if we have to learn 1's complement. So now after dropping the carry, we got the answer. If we have got the carry, we have just to drop the carry and add 1 to it to get the number. That's it. There may be some other situation where we don't have a carry. So if we don't have a carry, that indicates that this is a negative number, and now to represent a negative number, we have to do the same thing again. We have to find the 1's complement again and put the minus sign over there. Let's proceed to 2's complement. Consider this example that we have to subtract these two numbers, this number 0 1 1 from 1 0 1, then we have to find the 2's complement. That means 1 0 0, and then also adding 1 to make it 2's complement, because first of all we did a 1's complement over here, and adding 1 it becomes a 2's complement. And now I'm adding these two numbers, and now if I have a carry over here, I simply ignore it. In 2's complement, if we got the carry, we have to ignore it, whereas in 1's complement, if we got the carry, we have to add that carry, or maybe add 1 to the number and ignore the carry. But now if it is a 2's complement, if we got the carry, we can simply ignore it. There is a second situation over here. If we don't have a carry over here, then that is the indication that we got a negative number over here. Because we got a negative number, then again that means we have to put the minus sign and we have to take the 2's complement. So we already know how to find the 2's complement. First of all, we switch the digits. We put 0 in the place of 1 and we put 1 in the place of 0, and finally we have to add 1 to make it 2's complement. Otherwise it would be a 1's complement. So now in this way we got an answer. Thank you very much. If you haven't subscribed this channel, it would be great if you can subscribe this channel. Thank you very much. Have a nice day.